Hello friends, welcome to video series on geography. Sorry for the long pause, I had issues with my blog, so it took time for me to sort out things with my blog. Till now, under the video series on geography, I completed videos on geomorphology and then I made videos on various important concepts under climatology. This particular video on polar vortex is the last concept under climatology. So in this video, we'll see about polar vortex, ozone depletion and polar stratospheric clouds. Polar stratospheric clouds are formed during polar vortex event, and these particular clouds are very important because they deplete ozone, which is present in the stratosphere. So we'll see these things in detail. So polar vortex is a polar cyclone which forms over both the poles, that is the North Pole as well as the South Pole. And these cyclones are held in place by a strong jet stream, which is polar jet. So we have two different important jet streams. One is polar, other one is subtropical jet stream. So the polar vortex is held in place by polar jet, and when this jet is very strong, the polar vortex stays in its place, whereas when this jet weakens, in such a case the jet would slip into the neighboring temperate regions and brings extreme cold conditions in the temperate regions. And when the polar jet is very strong, in such a case the polar vortex will be very strong, and under such a scenario the polar vortex can reach to the bottom layers of stratosphere, touching the ozone, and the nitric acid which is present in the polar stratospheric clouds which are formed due to this extreme polar vortex event deplete the ozone which is present in stratosphere. So this polar vortex, when it is very strong, it is extremely damaging for the ozone, especially the one that is caused by the polar vortex at the South Pole is very damaging, and hence we have ozone depletion which is very significant at the South Pole. We have a very huge ozone hole which is due to mainly due to halocarbons which are used as major refrigerants in the 1970s and 80s. So we'll see all these things in detail. So polar vortex is a very huge cyclonic phenomena where the cyclone would extend till few kilometers. It might extend from the bottom layers of troposphere to the bottom layers of stratosphere. So its vertical extent can be about 20 to 23 kilometers. So it can touch up to the layers of ozone. And it is formed in the polar regions because of subsidence of air in the polar regions. We know that there are different kinds of atmospheric circulations, like we have Ferrel cell, Hadley cell and polar cell. So in the polar cell we have subsidence of air at the poles, and this particular polar cell creates the polar vortex because the subsidence is associated with convergence of air in the upper levels of troposphere. So here we have an extreme low pressure system which is responsible for this cyclone, and at the bottom layers it is subsiding air, so the pressure is high. Here we don't see much influence at the bottom layers, but this particular cyclone extends from mid layers of troposphere till the bottom layers of stratosphere, and its horizontal extent is very huge. It can extend up to few 100 to 1 to 2000 kilometers, whereas we have tropical and temperate cyclones which are much smaller in size, and they are held in place by jet stream which is also called as polar front, which is formed between polar cell and the Ferrel cell. So polar vortex is very strong when the jet stream is very strong, that is we can see here we can see a single polar vortex which is mainly due to a strong jet stream which is held in its place. When the jet stream is weak, that is when it starts to meander, it gives rise to waves called as Rossby waves. Rossby wave is nothing but a meandering jet stream. In such a case, the polar vortex is weak, it can slip into the neighboring temperate regions. And coming to how this particular thing slips into temperate regions, first we need to know a little about jet streams, where we have a meandering jet stream. The curve towards the equator is called as ridge, and the curve towards the pole is called as ridge, and the one towards the equator is called as trough. So the ridge region is associated with convergence of air, and here we have subsidence of air. As a result, extreme high pressure system are created at the surface of Earth, and in the other case the reverse happens and we have low pressure systems. So we have seen all these things in detail in the previous videos. So under such an influence we have alternating high, low and high pressure systems, like when we can see here. When the jet stream is weak, we have high, low and high pressure systems. So when these high pressure cells or high pressure systems are formed, they are usually pushed towards poles, that is in the ridge region. As a result, when a polar vortex is formed in this particular region, these particular high pressure cells squeezes this polar vortex, making it slip into the temperate regions. So under the influence of these high pressure cells as well as the low pressure cell which is created here, the polar vortex slips into the mid latitude regions, especially when the jet stream is very very weak, and it brings extreme cold weather to the mid latitude region. So we can see here, when the jet stream is strong, it will be, the polar vortex will be placed at the poles, whereas when it's weak it might slip into the neighboring regions. So it causes extreme cold wave scenario like it happened in USA and Canada about 2 to 3 years ago, and this is very frequent. It happens in every 5 to 10 years, and whenever it happens it brings very devastating climatic conditions in these regions, especially the flooding after the cyclone retreats is very damaging to the region. So the polar vortex is closely related to ozone hole depletion. So first let us understand what is ozone hole. Ozone hole is nothing but the depletion of ozone at both the poles because of the presence of polar stratospheric clouds, as well as which accentuate the reaction of halocarbons. Halocarbons are nothing but hydrocarbons where an hydrogen atom is replaced by a halogen atom. For example, let us take methane, which it is an hydrocarbon. So instead of CH4, we might have CH3, where one hydrogen atom is replaced by a chlorine or bromine or any other atom, which are called as halogens. Halogens are nothing but non-metallic reactive elements which are very reactive, like chlorine, bromine, iodine, etc. So when these atoms come in contact with ozone, which is called as O3, which is represented by O3, then they have the capacity to peel a oxygen atom from this O3 molecule. Hence Cl gets converted into chlorine monoxide. In such a case, the O3 is depleted to ozone, so the ozone is broken into O and O2. So this particular kind of reaction leads to depletion of ozone. So this is how ozone depletion occurs under the influence of halocarbons. Halocarbons are nothing but the hydrocarbons with halogen atoms, and halogens are very reactive non-metallic elements like chlorine, bromine, etc. So the famous ones which led to the depletion of ozone hole are the molecules like carbons and other molecules, and these molecules contain chlorine atoms, which is a halogen which is very reactive. So they were used as refrigerants during 1940s to 1990s, and after the Montreal Protocol these things were banned. They were both production as well as sale of these refrigerants was banned. They tried to ban it by the international convention, and in such a scenario these things reduced in their scale, and these particular halocarbons were replaced by other molecules like ammonia, etc. in refrigerators, and due to reduction in the use of these halocarbons, the ozone hole recovered slowly. It is recovering slowly, it has not yet recovered, but the main ozone hole depletion is due to because of these kind of elements like chlorofluorocarbons, etc. So this is how the ozone hole got depleted in just few years. We can see 1979 to 1984. This is how severe the influence of refrigerants like chlorofluorocarbons was. So we can see 1979 to 2013, we can see the recovery of ozone. So the ozone is slowly recovering due to the ban of production as well as use of chlorofluorocarbons as refrigerants. So what happens in the ozone layer? We know that in the stratosphere temperature falls in a particular region, and this particular region or layer is called as ozone layer. This is because the ozone here absorbs ultraviolet radiation, which is harmful to the species on the surface, and this harmful radiation is absorbed by the ozone, and hence the temperature increases. We can see here. So in the ozonosphere, this is what happens when a chlorofluorocarbon gets into the layer. First, under the influence of ultraviolet radiation, a chlorine atom gets detached from the chlorofluorocarbon, and it becomes a free atom, and this is very reactive. When it comes in contact with the O3, as we can see here, it peels a oxygen atom. This is like an unfaithful husband, so it doesn't stick with one oxygen atom. It keeps on changing lot of oxygen atoms. So here it was with this atom, and then it got another atom, so it combined, it left it there, and if it gets one more atom, it simply combines, and this cycle repeats, and this carbon chlorine atom can keep on doing this, or keep on destroying the ozone molecules for a very long period. So we can see in the animation here, we can see how a free chlorine atom can peel out an oxygen atom from the ozone. Here the chlorine atom is taking an oxygen atom from a ozone molecule, and now we can see how this chlorine atom is again free after peeling an oxygen atom. So this is a very kind of infinite process. As a result, this particular chlorine can be very devastating for the ozone layer. So what is polar stratospheric clouds, and how these polar stratospheric clouds influence ozone depletion? We have seen that under the influence of ultraviolet radiation and the presence of chlorofluorocarbons and other free radicals like Cl, this can be very devastating for the ozone, and this particular process of ozone depletion is accentuated by the presence of polar stratospheric clouds. Polar stratospheric clouds are very high altitude clouds. Usually clouds don't exist beyond upper levels of troposphere. Sometimes few cirrus clouds might exist in the lower levels of stratosphere, and there are clouds which are very, very high. These clouds are nothing but polar stratospheric clouds. These clouds are formed during extreme polar vortex events, so they don't usually exist in normal conditions. They only form during extreme polar vortex events, and extreme polar vortex events happen when the jet stream is very strong. And these polar stratospheric vortex clouds are dangerous because they contain acids like nitric acid and sulfuric acid. So due to the presence of nitric acid and sulfuric acid, these cyclones can be very detrimental for the behavior of ozone. Let us see what happens. We have free chlorine atoms which is already depleting ozone. We can see in this reaction where chlorofluorocarbon is hit by ultraviolet rays. And then it peels out a free chlorine atom, and this chlorine atom reacts with oxygen, giving rise to chlorine monoxide and then other elements, and these chlorine atoms react with nitrogen dioxide, giving rise to various reserves of chlorine. So these reserves are not dangerous because they consume this chlorine atom and keep it as a reserve. So this is not damaging because it can no more damage a ozone molecule. But when there is polar stratospheric clouds, it has very important thing called as nitric acid. Under the influence of nitric acid, these particular reserves can give up their chlorine atoms. So when they give up chlorine atoms, we know that chlorine atom is the biggest enemy. So when it's set free, it can destroy numerous ozone molecules, and it can do it for few decades. So you can imagine the effect these atoms have on ozone. So under the influence of visible light and under the influence of nitric acid, the chlorine gets separated from the reserves. So it is now free to create more chaos. So it keeps on destroying more and more ozone atoms, giving rise to oxygen, we can see here. And then these particular chlorine atoms are again set free, where they form a chain reaction. So the chlorine atom destroys an ozone molecule, giving rise to oxygen. And then we can see ClO, or chlorine monoxide, as we have seen in the previous reaction. Chlorine monoxide can again react with oxygen, that is free oxygen atom which is present, and they can give rise to oxygen as well as chlorine. So this chlorine is again available for more damage. So this is a continuous reaction where one single chlorine atom can keep on destroying numerous ozone molecules. So let us see here. So this is the first reaction where under the influence of ultraviolet radiation we have chlorine atoms, and these chlorine atoms, here we can see what happens. So under the influence of ultraviolet radiation, chlorine atoms reacts with an oxygen and takes away an oxygen from O3, and then it becomes free, here we can see, and again it starts repeating the same process. So when a free chlorine atom reacts with NO2, it gets fixed in a reserve. So this is the damaging effect is reduced. But when the polar stratospheric clouds are present under the influence of nitric acid, again the chlorine atom sets free. So we can see how a chlorine atom again peeled an oxygen atom, then it becomes again free again, and then it captures one more oxygen atom. So this is a continuous process. So in the normal conditions, usually somewhere the chlorine would stop as a reserve, but under the influence of polar stratospheric clouds, the chlorine atom would be free forever and keeps on destroying the ozone layer. So this is all about polar vortex as well as ozone depletion under the influence of polar stratospheric clouds. Polar stratospheric clouds are formed under the extreme events of polar vortex. So here is a question from previous exams. The formation of ozone hole in the Antarctic region has been a cause of concern. What could be the reason for the formation of this hole? Presence of prominent tropospheric turbulence and the inflow of chlorofluorocarbons. We know that chlorofluorocarbons are the major reason behind ozone depletion. Let us consider other options as well. Presence of prominent polar front. We have seen that polar front is the one that holds polar cyclone in its place, and this is very important in destroying the ozone because it can accentuate the magnitude of polar vortex. And then stratospheric clouds, as well as the inflow of chlorofluorocarbons. So we have three important points here. Absence of polar front. So absence of polar front cannot be a reason for destruction of ozone because polar front is very important in keeping the polar vortex in its place, and the polar vortex which stays in its place can destroy a huge amount of ozone. So this is a wrong option. Increased temperature at polar regions. This never happens. Even under global warming. Okay, under global warming the temperature increases, but this has nothing to do with the depletion of ozone. From this we can see that this is the most fitting answer, the option B, where we have the prominent polar front which is very strong, which creates a strong polar vortex, and polar vortex gives rise to polar stratospheric clouds, and these clouds along with the chlorofluorocarbons leads to the depletion of ozone. So these are the steps involved. First, chlorine atoms which is coming out of refrigerants escapes to the upper levels of troposphere because of wind movements, and then there it reacts with the ozone molecule, giving rise to free oxygen as well as chlorine monoxide. And then under the influence of sunlight and by reacting with the nitric acid which is present in the polar stratospheric clouds, it again becomes free chlorine radical, which keeps on repeating the process, destroying more and more ozone molecules. So this is a very important concept, especially under critical geographical features topic in the GS part of geography. So this can be important for the exam, both prelims as well as mains. And one important point is the Montreal Protocol. So this is a related concept, but it is a part of environment, so I have not touched too much depth of this concept. So Montreal Protocol is an international convention under Vienna Convention, which is formed mainly due to reduce the influence of chlorofluorocarbons as refrigerants, or completely cut down their production and sale so that the ozone hole won't deplete further. As a result of these such initiatives like Montreal Protocol, the ozone is slowly recovering. So this is all about polar vortex. Thanks for watching, and if you liked my videos, don't forget to subscribe. Thank you.